Parth. Hi, Jotishko. Hi, Ryan. Yeah? You enjoy it, Maya? Cindy. I don't know if Minecraft theme is copyrighted, Connor. Jeremiah, you're in the in the wrong channel. Hi, Vidya. We'll start in about a minute, and if you haven't printed this one yet, please go print it. And also, Jeremiah, senpai is for your peers, not for teachers. Teachers is sensei. No, it's not. It's not the same thing. Right. So, we'll get started then. Here we go. Okay, so today we're going to talk about segment relationships in circles. So before we talked about, so if you look at these three pictures, right, they look almost the same as the one that you have in angle relation, but we're doing segments instead. So that means it's the same situation, but what you're looking for instead is how these length segments are related to each other, like these segment length instead of the angle. Last week we talked about angles, right? So angle versus arc measures. Here we're talking about segments. Okay, segments. So today I'm gonna do explore segment relationships in circle, but there are several parts. Okay, so same thing, we have an inside situation, we have an outside situation, and we have a tangent situation. Okay, same thing. Today is the 4th of April. All right, so now let's look at this first one first. Okay, this one I'm gonna prove why the relationship is correct. So here, the relationship they told you for conclusion, if you have some random cross in the middle intersection, then AE times EB is equal to, they say, CE times ED, right? So that would be this one times this one. Okay? Say this times this equals this times this. Now, at first it may seem weird, right? Why would that be true? Okay, so what we're gonna do instead is I'm going to connect two lines. Okay, I'm going to connect this CA and BD. Can you tell me how are these two triangles related? How are they related? Okay, they're vertical angles. That's one angle congruent. But I'm talking about the whole triangle, these two triangles. How are they related? So they have vertical angles congruent, that's correct. They're similar, Cohen said. How would I say that, why would they be similar? We do not know the lines are parallel, so you can't use alternate interior angles as such. They could be the same, but they're not parallel. So parallel meaning like these two have to like not cross in the long run. How about, let me help you a little bit. Look at this angle versus this angle. These two angles. How are these two angles related? Looking at these two top angles. How are they related? Cindy said they're congruent. How come they're congruent? How do we know they're congruent? You forgot a specific theorem? They're both connected to A and D. What is this called? So basically what you're saying is, okay, you see this angle versus this angle? Do you see this arc right here? This arc right here? Right? This arc is the same arc, right? And remember, these are called inscribed angles. Inscribed angles are exactly half of the arc, right? At arc measures. Since they're about the same arc, of course, these two will be the same measure, okay? So congruent angles here, congruent angles in the vertical, so they are similar. Two similar triangles, then how can I say this times this equals to this times this then? Well, because this is in proportion, right? So basically it comes down to this over this is the same thing as this over this, right? So like this. CE over, let's do, because these two are corresponding, right? CE over AE is equal to BE over ED, right? And then you cross multiply like that, and you get this. Okay. Is that all right? So you're using the similar proportional theorems, right? And then when you cross multiply, you would get this theorem. Okay. Similarly, you will have the other two theorems as well. I'm not going to prove them, but they're the same, similar ideas to prove it. You get it? Similar idea. All right. Anyway, you don't have to laugh. It's okay. So all right, so let's look at what the rest of them say. Okay, so the rest of them basically says this. This one is AE times BE. So AE times BE is equal to CE times DE. Okay. And the last one is AC times BC equals to DC squared, right? So basically DC times DC. Okay, like that. So why don't I say DC squared? I say DC times DC because they all follow the same pattern, and we're gonna discuss the pattern here so that you can remember how to do them. Okay, here. So every single one of these situations have an intersection point, right? So I want you to circle the intersection point real quick, or mark it real quick. So here, first one is here, then here, then here, right? These are intersection point of the two lines. So like this one is intersection, this is outside, this is outside, right? So this is called inside, and this is outside. This is tangent. Why do I call it tangent? Because one of the lines is a tangent line, okay? But it is still outside, okay? So let me tell you how I remember it so that when you do it, it would make sense to you to do the same, okay? So to remember it is sometimes you just need to make sure you don't get confused. So you always start from the intersection, okay? So that's the intersection point. We're going to pick a line, okay? So it'd be intersection to the circle, okay? So to the circle. This times this, okay? Intersection to the circle, okay? Is equal to this times this, okay? This times this equals this times this, okay? On the next one, intersection is here, right? Intersection to the circle, okay? Pick a line here. Intersection to the circle is here, right? This. And the next part is not this part, okay? It is not this part. It's the whole thing from intersection to the circle on the other side. Okay, so this times this whole thing is equal to this times the whole thing. So intersection to the circle, where you touch the circle, right? Intersection to the circle, intersection to the circle. Okay. Last one. Intersection is here. Intersection to the circle, intersection to the circle, this times this equals intersection to the circle times intersection to the circle. Okay? Since these are the same, so that's why you get the square in the tangent, but you still have to do it twice. Okay? That's the idea. Let's practice with one. Am I going too fast or am I okay? Alright, so let's take a look at this one. So find the intersection first, right? Intersection is right here. Thanks, Chance. X is this part. JH. FJ is gonna be 7. Yeah. Okay. So J is here. That's the intersection. So we're gonna use. You want to find X, right? So it will be this times Z. Set it up. X times 14 is equal to 7 times 10. So 14x is equal to 7 times 10 is 70. Right? So together, x divided by 14, right? So it'll be 5. How are we doing? What? 3.75. The one on the right? Yeah. Okay. Let's look at the. How about you do this one first? Okay. I want to make sure that you can at least apply the theorem real quick. This shouldn't take too long. All right. Okay, so intersections here, right? So pick one line. 6 times 5 is equal to, so 30 equals 8x. So x is 30 divided by 8, so we get what? 3.75. And that's it, okay? Seems like it's lagging a little bit, but it's okay. The frame should pick up a little bit, just a little bit hiccup. Getting notification from YouTube saying that it's a little bit lagging, but should come back up nicely in a bit. Is it still okay? A little bit laggy? Okay. So next one, look at this one. So intersections here, right? So before you start, you have to be careful about this kind of problem because it's this times the whole thing, right? So intersection to the circle, okay? Not intersection to circle, circle to circle, okay? So intersection to the whole circle. What's the whole thing here? 7 plus 9, right? So that's going to be 16. Okay, so the first part, 7 times 16 is equal to 8. And then the whole thing here is not just x, is 8 plus x. Right? So 8 times 8 plus x. Okay, so then you multiply out. 7 times 16 is what? 112 plus 8x. Distribute this, right? Okay, and then you calculate this out. 48 equals 8x. X would be 6, like people have been saying. Okay, we'll do one more together on the bottom. Okay, so if you look at this, same thing. You gotta make sure that this part is accounted, right? 10, 5 and 10. So 5 times 20 is equal to x times x, right? X squared. So 100 is x squared. X is plus or minus 10, but you're doing length, so x is just 10. What's up? Okay. So, I'll give you some time to do the right side. It shouldn't take too long, but at this time, I also want to take attendance. So if you're here, just type here so I can count you guys real quick. All right. Go. Who's B? Who are you, B? Oh, Belen? Is Shervine here? It's fine. Where is Sherveen? Sherveen, if you're watching, leave a comment. If not, when you later on watch the video, leave a comment. Alright? He's absent. Oh. Layla, you around? Oh. Layla's here. Never mind. Yeah, I got you. Emily? Let me see. Yeah, Emily's here. No problem. Olivia? Olivia, where are you? Wonder where she is. Who's you? Olivia? Olivia is not here. You think she's here? I never seen her today. Yeah, why is she... Tell her Mr. Cole is very disappointed. That she is ditching class. Anyway, so... Alright. Looks like I'm missing Olivia, and that's it. I know. Imagine ditching Mr. Quo's class that only appears once a week, and with everything we've been through, she's still ditched class. No, she's not. It's hard to come up. Alright, let's talk about these two problems first. Olivia, if you come back up later, just let me know. Seriously. Alright, so let's look at these two problems real quick and go over the answer. So this one, you just need to make sure, like, outside situations, you always account for the whole thing. So the whole thing here is 39. Alright, so 9 times 39 is equal to 13, and then this is 13 plus z, right? Like that. So the setup is that, but then when you do it, you can actually simplify it first before you go, because this is a lot of multiplication, right? So 39 and 13 actually goes in, right? So it'll be 3, right? 13 and 39, 313 is 39. Okay, so multiply it together. 27 equals 13 plus z. So z should end up being 14. Okay with this one? I mean, no matter how you do it, as long as your setup is correct, your answer should be the same. Okay. And last one is this one, which is a tell her to send it to my email. The picture, okay? The picture she just sent you, tell her to send it to me, okay? Then she'll be fine. All right. So this one will be. Oh, no kidding. See, Cohen's pointing out the obvious. You don't have to make an account. You just need to log in with your student account. Right? So here is 7 plus y equals where? And then 10 squared. So 49 plus 7y equals 51. 7y is, sorry, blah, 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 100. 7y is 51, and y is 7.29. Or 286, something like that. Okay? Where? I don't see it. Chat box. What are you doing, Jeremiah? Who's this? Yo Ramane. That's Hillary? Oh my goodness. See, this is why we need to log in with your school name instead of your thing. Because but anyway. Shireen's not here though, right? Okay. Okay. Before we go, I want to make sure everyone knows that you need to go on bigideas.com, math.com to do the homework for this week. You need to go watch the video. The stream is ending soon. So the access code should be in the email that I sent you about the change. Go to the email that I sent you there. I'll put it out. Okay, I'll put it out here so that you can come in. All right, so that we don't have to worry about it. All right, let me copy and paste here. Okay, it's here. There. That's it. Okay, this one. This is the code. And you go on bigideasmath.com. I think it looks like this. Don't use the one in the video, Colin. You're gonna go to 4th period. That's an epic fail. Because the one in the video I use is 4th period code. Gotta use the one in the email. You have to create an account, Jeremiah. Like, just say new. Dude, go watch the video. I made a video just for this. Go look at your email. In the email, there's a video explaining all that. Yeah, that's what I'm saying, Cohen, because your code you're using is Geometry 4, and I can't move you. The options I have here is very limited. But I mean, if you're already in 4th period, then you're in 4th period, okay? Don't worry about it, okay? Just stay in it. Unless you really care about it, then you want to move, then you can move it. Yeah, because so the reason why we're moving it to online is because there's too many issues taking pictures and sending them on School Loop, which is part of the reason why we're moving away from School Loop. But basically, this allows you to check your answers right away, and it allows you to get help when I'm not around. But you can always, there's no homework assigned right now because I have to add you to it. If you just join right now, then I have to add you to the assignment. Okay, so right now, if you just join, I'm gonna start adding people here. Okay. Let me see. So right now, the people that just joined, I am going to add you to the homework. So now if you refresh the page, you should be able to see the assignment now. Okay, this is the only assignment for the week. Make sure you finish it. Yeah, both classes is fine. Just choose to join. Once you join both classes, I'll just delete you from 4th period. Okay. Oh, you can join both? Yeah, I just saw you, Cohen. So I'll just delete you from 4th period then. So I just added Avia as well, I think. Still missing a few people, so start adding. Make sure you know how to do that, okay? Okay, so any other questions before we go about logging in to Big Ideas Math? Oh, I see Olivia. No, don't call me. All right. If nothing else, then this is it then. If you have any questions, you can hit me up in Remind, or you can hit me up on an email. I'll try to answer it. If you have any questions you want me to do personally, you don't click on login, you click create an account, Belen. You create an account, and then you use the code I just sent in this chat. This code right here. This code. Use this code. This is due Friday, correct? It should have due dates on it. Okay. If you're okay, then you can start leaving. It's okay. I'll stay for another extra 3 minutes to answer people's questions. All right. How are we doing? I am going to all right, Cohen, I'm going to delete you from fourth period. All right, goodbye. Yeah, goodbye. We're good.